Hello everyone and welcome back to How to Build Like AWS, the show where we take real customer stories and speak to the developers behind them so you can build solutions like multimodal data processing for improved driver experience. Yes, we're doing an automotive story today, and Eric has joined me, or on my wrong side, Eric has joined me today, and I'm excited to dive into this subject with you all. Throughout, please make sure you add any comments, questions in that chat. Also, if you're watching us on demand, comment in the YouTube video. I will keep an eye on that and reply to anything. But Eric, why don't you kick us off with your 1-minute origin story and the first app that you ever built?
Hi, thank you. Thank you for having me, Steph. My name is Eric Borland. I'm from Barcelona, originally from Barcelona. I work as a senior solutions developer at AWS. Been in the prototyping team now for about 5 years, and I'm loving it. It's amazing. First app you said, so that was quite a long time ago. And I would think like the first full app I actually built was one of my startups that I had that time ago. That's still running, it's still up and running, and it's about for soccer or football, the coach or players or trainers that they want to like create the planning sessions, the trainings, the drills and whatnot. Because I was a coach back then, so that was the first thing I did for learning and for also like for my own before job. So that was the first one.
That is so cool, and I love that it's continued after you continued developing, which is very impressive. Love building out stuff that it lasts. So today we're going to be talking about Valeo and this amazing project that when you told me about it, I was like, this is fascinating, about how they used all this data to course correct if any kind of wrong alarms were going off in cars. Eric isn't explaining it much better than I can, but if you are looking to find out how you can do some multimodal data processing or how to use data you already have to find something out about what's going on in your application, this will be the episode for you. Eric, do you want to just do just a quick overview of who Valeo are as a company, just so that everyone knows?
Yeah, so Valeo is like a car part manufacturer. So they build cars. They build car parts, hardware mostly, but also part of software, and they sell it to big OEMs, like big car manufacturers.
Okay, perfect. And what was the problem that they had that you guys were able to come in and do the working backwards approach with the DI team to help build a solution?
Yeah, so the main problem, so Valeo is based in France, the headquarters, and one of the issues they have in France, and I think like it could be extended to most of the globe, is that more than 90% of the emergency calls that are happening within a vehicle, you know, that SOS button that you have in your car. So more than 90% of those calls are not actual real emergencies, right? In some cases, it's just maybe kids playing around the car and pressing the button, or it's maybe a flat tire and people get kind of angry and they press the button, right? So it's not really like life-threatening emergencies.
Right.
So they wanted to kind of like try to not overload the emergency services with non-emergency calls.
Okay, that makes sense. I actually, when I was talking to you about doing this episode, I asked my dad about it, and he said, "Oh yeah, I've definitely hit that button before." And I don't have a car, and so I didn't even know it was a thing until you mentioned it. So of course, if generally people were activating this, then you don't want any kind of these alerts to come off. So we're going to go into how you built the solution to help validate what was correctly kind of emergencies that we needed to follow, but also ones that you could just kind of dismiss and validate that, like maybe there was the kids playing around, right? When it came to the car, did you guys have to change anything about the car to get this kind of information?
And that's interesting because one of the main goals of Valeo with this solution was to reuse all the existing hardware that we have today on the cars without needing any extra equipment, right? The cars today, they already have a lot of telemetry sensors in the car, or even cameras inside or outside, right? So the main goal was to use the same that you have without needing any extra hardware, only software, and improve the emergency services.
Okay, that's great. So it's like no real changes at all. We've got a couple of people saying hi in the chat. Hi everyone, that's my one. Someone said excited for the show, which is great. We've also got Jazz saying thumbs up, I love it. We had a quick question, which is, did you use AI for this? So the short answer, yes. But yeah, we'll go into a little bit more about specifically what models and stuff like that that you guys did. But questions, keep them coming in the chat, everyone. So you didn't have to do anything with the cars, but what kind of data did you need to pull in I need to figure out how I can explain to filter out the accidental causes. Yeah. So what data did you use?
Yeah, and that's a good explanation, right? Filtering out the good ones from the non-emergencies. And we use primarily three kind of data. Okay. One was audio, the other one is video, and the other one is telemetry from the car. And the telemetry, this can be like various, depends on the sensors the car has available and whatnot. But the main one, the first one, the main focus we had was on the video, because that gives us a good, fast understanding of how critical the emergency can be.
Okay. And was this video outside the car, inside the car, both? Was it
both? We like the plan was to use both. For the very first pilot we did was only interior of the car, but the idea was also outside and to see like what other cars are doing around, if there is a smoke or not, or there is pedestrians outside and things like that.
I love that. And like you said, already using information that was had, which is a good maybe suggester for people who are building, if you're watching this and trying to learn how to build more like AWS, which is hopefully what people are doing, is always try and see what data you have available, because there's often so much you can pull out of these things, and especially with the AI conversation, that you can extract nuance and data and information through it. People, I think, often jump to, oh, we need to build something new, oh, we need to go and get extra stuff and pull this in. What do you already have, and how can you use AI to determine what is valid? So how did you start with this? You obviously have the video, but where did you start with trying to investigate if it was this accidental data or a real emergency?
So of course, we use Gen AI for this, not just basic ML, right? And the idea behind Gen AI, and because we have different modalities of data, right? So the idea was to be able to have one single system that could use the different modalities. As I said, the first one and the main one was video. That's how we started off. We had some sample data with videos of that. And then from the video, we also extract the audio, for example, and we kind of like understand the conversation that's happening, if it's happening a conversation within the car. Because that also hints you between a real emergency when no one's talking, for example, or an emergency, which is not that emergency when there is a flat tire and someone is just very angry about it, right?
Yeah, so, very different conversation to, oh no, or like silence, everyone's been knocked out, versus, oh, the car's broken, I have to pay for it. Probably some obvious differences. Yeah, okay, continue.
No, and so answering the question how we started with a video piece, because that's how we think was like the most valuable one. But at prototyping, we always do this like very small increments that gives value already, right? So once we had that, then we plugged in also the conversation recorded from the car, then also the telemetry and whatnot. But yeah, the main thing was starting with video. Already Gen AI is already ready for any other kind of modality. And at the same time, and this is also interesting from what you said before, right? It's not just AI or ML, but it's Gen AI that allows you to very easily adapt to what data you have, right? If we didn't, for whatever reason, if the car is, I don't know, it got several hit and the sensors are not working, we still can work with the other modalities. If the voice is not recorded, we still have the video and the telemetry or the other things, right? Or if we don't have the video, we still have at least the audio, right? So that's kind of like how, that's why we use AI and Gen AI, basically, because it's very easy to adapt to what kind of data you have available.
Yeah, and that's also interesting that there was almost a backup data. So if something had happened and maybe there had been an accident and the camera had been broken or the microphone had been broken, it would mean that you wouldn't have that. You could go off the other data, and then really, especially in those situations, something bad, really bad might have happened. And so you want to validate those. Excellent. And just in case people want to read more about this, I'm going to throw this up there. There's a press release blog kind of summary of this, which you can link. Grab that from the chat wherever you are watching. So when it comes to AI, were there any specific models you want to shout out of things that you used?
So yeah, the main thing we used was Amazon Bedrock with our own hosted models. And by that time, because this was already like a year and a little bit more ago, we didn't have the Amazon own Nova multimodal models, but the other ones we have very powerful as well are from Anthropic. So we use at that time Sonnet, I think was 3.5. That's the one was available by then. But I also have to say that in recent engagements I've done and recent solutions, not for emergencies, but also for video processing, we've been using Nova Pro, and it could have delivered just as well as of today, right? So it's that's one of the good points of Bedrock, that you can switch and test different models and then compare between each other. We actually did that with the ones that had available by then. And now it would be just as easy as to change like the endpoint URL. So one single line of code, it would just work as well with other models.
Yeah, I love this. We also had a quick kind of good morning. Hello, good morning, everyone. Feel free to drop any comments, questions in the chat. We also had a question, which was, how do you choose a model? So I guess when it comes to AI, there's obviously so many, you mentioned there's a lot that are coming out. What are any kind of quick wins people, how to differentiate what's going to be best for them?
I think, and I don't think so. I'm enough to give like a thumbs rule, right? The main thing, and that's why we actually do prototyping, and it's one of the good points of Amazon Bedrock, right? It's that you should test with your own data for your own use case, and test as much as you can, right? Not for a year, but at least give us some like pick few examples, and with the same examples, test different models and see which ones are best for your data and your use case, because it might depend on what kind of data you have and what kind of use case you have. How we did it exactly like that, we had like a baseline success criteria. We wanted at least achieve 90% of accuracy and response time less than 8 seconds, I think it was. So with those like key metrics that we wanted to at least improve or at least make it equal, we test different models, that the ones that were available back then with multimodalities. And then we chose with the one of course, we did some benchmarks, and then we chose the one we thought was performing better and had better, like, of course, there is a trade-off on cost and response time. So the one that had a better overall score for us, that's the one that we picked.
Nice. And John's commented, nice feature of Bedrock, compare performance models, really cool. Agree. Brilliant. So let's get into a little bit more of, you kind of went through, you had a conversation, the technology you've hinted at, but a big part of this is that multi-model data processing. So being able to use both of them. Can you talk us through kind of, obviously you mentioned why you did this, but what does that look like, how you combine these things to shed some light on the technical aspects?
Yeah, so, and this is also available within the Amazon Bedrock's APIs and some particular models, right? So when we talk multimodalities, like different types of data, right? When we say video, those are images. We actually convert the video into frames, so those are images. So it's like PNGs or things like that. When we say text, for example, is some like whatever comes from the telemetry. In this case, we also convert the audio into text, because finally the meaning is the same, right? You could maybe get some extra level of details if you have the audio itself, like if there is a siren or something like that. That's not actually a conversation. But by that time, there was also no text, like sound models, or voice models. So we were basically using these two, multimodality in terms of images and text, where within text, we have actually two other modalities. One was telemetry, and the other one was conversations.
Okay. And then when it comes to other data or other technologies, you mentioned a couple to me. What are some other things that you use to kind of make sure this thing actually works?
Yeah, so around Bedrock, of course, Bedrock is a very core service. You need to plug in some other things around so that the cars can communicate to it, that the emergency responders can also see the data and what's coming on, right? So we built some small front end. We also have some API gateway. We were using WebSockets and Lambda resolvers. So Lambda is kind of like the one plugging all the things together and triggering Bedrock itself. But the communication between the front end and the car itself, which in this case was the back end, it was on through WebSockets. So we had an open connection, so we can have a faster response time. So as soon as the model made a decision, we get back the decision to the emergency responder, so it can easily filter out which one is an emergency or not.
Mm-hmm. Okay, interesting. I know we spoke a little bit about the WebSockets because it's. Do you want to explain a little bit more what that is, people who maybe haven't heard that term? I know you said it was like an open kind of communication, but did you say that? I think we were talking about like this kind of communication would be open, via WebSocket, right?
Yeah, definitely, right? This is probably WebRTC or things like that, which is based in WebSockets. So it's just transmitting packets back and forth in a continuous way, right? Anything that does a streaming is usually doing it that way, rather than having a REST API that you need to call every time and get a response. We just open a WebSocket connection. Now there are other technologies you can do similar thing, right? But we chose WebSocket because it's natively integrated in API gateway, and yeah, then as soon as the model makes a decision, then the client is informed at the same time, in terms of milliseconds.
So it's a lot faster, and when you kind of need, especially in this kind of situation, when you need the speed, that is important. Just going back to the I realized I was saying multimodal. I was reading it as model, multimodal processing. Someone's asked just a clarifying question. So the model can have two input types, both images and audio, correct?
In this case, we're images and text. But
because you translated the audio into text. Okay. Was there any reason why it was not audio?
Because they were not available, the models that can now understand audio itself.
Okay. And does Nova allow this now? I'm trying to remember.
I'm not sure if with Premiere you could do it now, something like that, or it would just internally also only understands the conversation. Because whenever we used conversational model, is for conversations. I don't know if they would understand a siren going off or something like that. I'm not aware of
okay. That makes sense. There's a lot of different things, and also I guess translating it, you can add some translation elements to it where you can translate it probably from French, which is where it is, and you have to also deal with common languages. So you're looking for words like tire or crash or glass or something, so that you can grab those and filter out. Great questions, everyone. Please keep them coming. Also, if you have not and would like to, please fill out the QR code at the top of the screen to provide any feedback. Or if you would like us to touch on a subject in specifics, please fill that out. So we've spoken a lot about the different technologies and stuff like that. When we were talking about the model analysis, I always have to ask people, what did you find anything fun or interesting or useful when it comes to building out this solution? I think we talked about the amount of images. We were kind of prepping for this.
Yeah, so you mean the two use cases we had?
So we were thinking, were there any like fun features that you found when you were developing? I think we spoke about like the amount of images that you could have, or anything people should know if they're dealing with AI models that have to ingest a large amount of images.
Maybe not fun, but kind of like important or interesting to do, because when you're using images, you're limited the amount of images you can actually process, because a video feed may have 30 frames per second or 60 or 120, right? Those are too many frames to process in just 8 seconds. So you should, of course, reduce the frame rate. And then when you reduce the frame rate, you're actually losing some of the frames. You're discarding some of them. One of the techniques we use here was to know which frame is the best to choose, right? Within a span of a second, which is the best frame of those. And for that, we use the very simple mathematical calculation which gives us how much focused is the frame, right? So we discard the ones that were more blurry, and then we only take, if let's say 1 frame per second or 1 frame every 3 seconds, we only take the most focused one. And for that, we use actually the Laplacian variance. So the one that has a higher variance, it means it's more focused because the edges are sharper. So we can like make sure we're not using the blurry images.
Oh, wow. That's very clever. That's something, I guess, well, especially, and again, we're thinking about incidents where there might be an accident. People might be moving around a lot, or there's the car might still be in motion. That is fascinating that you had to live with that, all because there was a limiting factor, which is, again, when we're talking about this show and how to build, we're trying to give suggestions and tips and advice people how to deal with these kind of problems to encourage you to think outside the box. So you took something that was a limiting factor of the maximum amount of images you can handle, and found the solution to be this new way of looking at images that were how focused they are. That's just really clever. I'm always inspired talking to you guys. We have a quick audience question, which was, what was the most challenging part of implementing the solution?
Yeah, I believe the most challenging was probably getting it in the response time in less than 8 seconds. Because as I said, you have to split the video into frames, extract the audio, convert the audio into text, then get all the telemetry from the car as well, and then all this plugged into the Gen AI model, and then get a response. We were playing a lot with, of course, the video frame rate. That's quite crucial, because the less frames you take, the faster it is. Also, we implemented like some sort of 2 responses. So we ask 2 times to the model with the same kind of data. We ask 1 time, give me just the number 1 or the number 0 if you think this is a real emergency or not. Right? So ones would be, and so the model doesn't need to generate anything, only the number 1 or only the number 0. That makes the response time much faster, because usually those models generate text, right, or JSON or whatever. That takes a long time. But if you ask them only generate the number 1 or the 0, and then we ask another question separated from that. Once we have the number 1, we already send to the client saying this is a real emergency, and meanwhile that happens, the model is generating the actual response. So I think this is an emergency because I see people that is like passed away or passed out or whatever. They're not speaking, their eyes are closed or things like that. So we kind of like separate the decision to the explanation of that.
Yeah. So that's because, again, these situations, you can't spend time while you're, especially if there's an LLM creating like, oh, I think it's because of this, and I think it's because of this. You're like, is it a yes or no situation? And then you can deal with the aftermath later. And then I guess it's gonna, once it gets to that, yes, this is an emergency, you then you need the follow-up data, and they can review it. That's very clever. So it's all about that speed. And I'll skip ahead to one of the questions that we were going to have, which is, what was your success criteria for this? And you mentioned it was getting it below 8 seconds for the response, right? Was there any reason it was 8 seconds, out of curiosity? Just an arbitrary 8, or?
Don't remember. I think it was kind of arbitrary. Maybe Valeo knows why they asked for those 8 seconds, but that was their request. Maybe there is some science and some statistics around it. I'm not aware of.
Probably. It's hopefully not an arbitrary number, but it's also a good goal, which is another thing. When you're building out solutions like this, having a success criteria is so crucial to understanding if it's doing a good job. So it could be sending messages and you're like, yeah, this is okay. But then because part of this is reducing the error and also creating that speed, it's very important to have this. And someone just said, I like the idea of frame aggregation. Yeah, it's very clever and just awesome way of figuring out how to get that data that you actually need. So we're going to do a bit of a demo. And when I say demo, we're not going to demo the whole product, because we're not going to get someone in their car driving around and then getting record the SSS. But Eric has a couple of kind of screenshots and summaries. Eric, you're right to share your screen?
Sure.
All right, let's see. Perfect. So what can we see here?
So here we can see one of the frames of the video that we were feeding into the model. Along with this frame, we were also feeding, as I said, the conversation in the car and the telemetry of the car. And in this case, we can see like one woman who is clearly not feeling well, and the driver in distress because trying to help her. And the 2 responses from the model, as I just explained right now, right? We have like this red alert sign. This is an emergency. That was the number 1, right? So the model, the first thing responds is the number 1. And then it takes its time to like produce the full output afterwards, which is like the justification why it thinks is a real emergency. And in this case, it says based on the images provided, we see there is a woman, a passenger who is slumped forward with their hair dropping down and things like that, right? Then it knows that the vehicle is stationary. Well, some other data from the car as well, or even the conversation, oh my God, and things like that, so they can understand what's happening here.
Okay, yeah.
And this is another example, right, within a very similar vehicle and similar or different situation in this case, where, again, the button was pressed, and for some reason, this was not a real emergency. So that's what the model, the first thing it says is this is not an emergency, so it doesn't need the urgency than the previous one. It might be still an uncomfortable situation, but not a very urgent emergency. In this case, if you read through all the, like, why the model thinks this is not a real emergency, it's because they are complaining that there is a flat tire. So there is one of the sensors that say that the one tire pressure is not correct. And then they also say, we have a flat tire, but where is it? It's front or rear and things like that. So that's the conversation that was happening within the car. So that's why the model in this case understood it's not a real emergency.
I see. Okay, it's cool that it kind of gives you both of those aspects, but like we said, that yes or no straight away, and then some of the data behind it. Now we've only got a couple, like 2 minutes before we finish. Time has flown by. We wanted to look at a bit of how you did this in some of the code. Do you want to jump to that quickly and explain to folks what we saw?
Yeah, well, the code is like, the code base is much bigger than this, but this is like that example we were talking about that can be interesting or fun, which is how to, within a video frames or multiple frames of a video, how to find the most focused one or the less blurry. And in this case, we use, as I said, the Laplacian variance. So this line that we have in here, that's basically calculating, using OpenCV, calculating the variance that it's within that frame. The higher the variance, the sharper the edges, right? So whenever something is focused, you would see more difference, more contrast in colors and edges. So the higher it is, the less blurry. So we assume less blurry. So we ran this through all of the frames. That's why we have this for loop. And at the end, we just take the one which has the highest, so the best one. And that's the frame we actually use to feed into the model. And we do this process every X seconds, right? Depending on the frame rate we want. So that's basically the whole code of just extracting given 10 frames, 20 frames, 30 frames, which is the best one of them.
Yeah, so Laplacian method, if you need to get your frames that are the least blurry, check that out. Okay, we're almost at time. Thank you so much for joining us. A couple of little things. If you would like to see the future episodes or past episodes, check out our How to Build Like AWS link page. This is where we have all the information of our past shows and future shows and on our LinkedIn and stuff like that. If you would like to read more about this solution, then check out this blog post. And if you would like to learn more about the team that we are both in, check out the Customer Acceleration team page. We also have this session from Eric is doing a reInvent. So if you're going to reInvent, sign up for AIM 404 and you will see us around at reInvent. Come say hi. Let us know if you have watched the show. That has been it for us. Thank you so much for joining, and we will see you all in 2 weeks' time. Bye.